Howdy y'all, it's the Diabolic VTutor here, and we're going to be covering some more of the trig functions, just the basic trig functions, which basically means SOHCAHTOA. Let's get started. So no particularly new rules today, we're just going to be making sure that we go over sufficient problems covered from prior streams. So let us begin. So starting off with something from, I guess, last time. We have cosine of x is equal to negative 1/2. And then furthermore, we have tangent of x is equal to root 3. And then lastly, there is a question asking you to evaluate what is sine of x minus pi over 3. So that is the first problem. So what kind of thing are we dealing with right here? We have this portion here, which is basically solve for x. X is going to be some sort of angle argument. And then we have another equation where the x angle is inserted yet again as an argument. So from those first two clues, from this one and from this one, we can narrow down what the x angle is. We won't get an exact answer because we're going to, whatever angle we get, we're going to slam dunk that right back into the sine trig function, and we're just going to evaluate that. So we don't need the exact value of x, but we may need multiple values of x, maybe, depending on the circumstances. So first clue number 1, as a quick sketch, where are we on in terms of the quadrant? We have cosine of some, again, angle argument gives us a ratio of adjacent negative 1 over hypotenuse 2, which basically means we have a triangle. We have a reference triangle either here in quadrant 2 or there in quadrant 3. Because therein lies the negative 1 adjacent ratio to a 2 hypotenuse or to a 2 hypotenuse. So that means that we can have an opposite ratio of what? Root 3 or negative root 3. So that's just coming from the first clue. And then of course from the second clue we have tangent of this same angle will give us a ratio of root 3. This doesn't look like a ratio, but you're always entitled to put it over 1. So there's the ratio. So tangent is opposite over adjacent. I goofed up on this problem. Oh no, I didn't. Never mind, I didn't. Okay, I thought I messed up on the problem for a moment. So again, from this first statement, we can infer that the angle argument could be in quadrant 2 or it could be in quadrant 3. And then from the second statement, this one right here allows us to eliminate one of these possible choices. Now we could sketch out the other scenario where we do get a tangent of positive root 3 over 1, which could be in quadrant 1. We could do that, but in my opinion, we don't really need to do that, since the angle that generates this reference triangle is not applicable to the first statement. So you don't need to state this part right here. Alright, and because of that, which one is it, right? Is it going to be this one or this one? Well, there are two ways to make a positive root 3. We can have a positive root 3 over positive 1, or we can have a negative root 3 over a negative 1. And the two signs will cancel to produce a positive root 3, which means both the adjacent and the opposite are negative, which means it's in quadrant 3 for the reference triangle. So it ain't going to be quadrant 2. Nope. So we're looking right here. What angle in particular is this one? The angle here is going to be, if you memorize the ratios of a 30, 60, 90, it's going to be 60 degrees, or in other words, pi over 3. But it's pi over 3 spillage from half circle. So make sure you don't just write the reference angle, you have to write the actual angle from here to there. So just add a full pi, a half circle. So thus summating those two, we're going to get 4 pi over 3. So that could be the angle for x. So x could be equal to 4 pi over 3. Now I say could be because we could potentially have to worry about the coterminal angles for this one, because this is only one of many angles that will satisfy the argument requirement for having these particular ratios. But that, again, that's just one angle. So if you add or subtract variations of 2 pi or 360 degrees, you will get to coterminal angles, which will also fulfill these particular ratios. So in terms of writing a statement for what x is, you can put plus 2 pi k, where k is an integer. But we don't particularly care about this because we're just going to take this one and slam dunk it back in here anyway. So this part right here is a little extra. We're not exactly evaluating for x itself, but it's nice to know what x is. So we're just going to use this most basic, what's that called? Coterminal angle for x, the smallest positive value for x. We're just going to take that and we're going to plug it in. Because again, caring about the coterminal ones, the question isn't what's the value of x. The question is what is sine of x minus pi over 3. So we're going to use the lowest possible one, the lowest possible positive one, and slam dunk into there to generate our answer. Because if you add or subtract variations of 2 pi, it doesn't matter. You're going to get the same ratios regardless. Alright. So let us do this one. Plug in this most basic number again. So we're going to have sine of 4 pi over 3 minus pi over 3. And that is going to be equal to what? Simple evaluation right there. It's going to be 4 minus 1, which is 1 pi. So our problem essentially devolves into this one, sine of pi over 3. And, wait, do I not know how to do math? 4 minus 1 is 3. So we have 3 pi over 3, I'm sorry. For the simplification, and simplifying a bit farther, we're going to have sine of just regular pi. Do recall this is an interquadrant angle. What are the particular sine ratios? This is going to be the quote-unquote collapsed triangle. So it's going to be a situation where the opposite is equal to the hypotenuse. So this is going to be 1 to 1. Or in other words, just 1. So you can memorize this. You can reference your, what are those things called? The handy dandy little charts that teachers sometimes give, or sometimes force unfortunate students to memorize. It's called the unit circle. Yes, the unit circle. But it doesn't matter which method you use. We're supposed to end with a 1, right? Okay, so that's going to be the situation with that one. And just to illustrate why having this part doesn't really matter, let's try a situation where we're adding one more 2 pi to this one. So the situation is done, but I'm just want to illustrate a little point. So why doesn't this part matter right here? Well, if you add 2 pi to this one, let's see what happens. So we have 4 pi over 3 plus 2 pi. And then just changing this part into equivalent fractions, we're going to get 6 pi over 3. And therefore the sums to 10 pi over 3. We're going to take that and slam dunk it into there just to evaluate, thereby getting sine of 10 pi over 3 minus pi over 3. So just simplifying this a bit, we have 10 minus 1, which is 9. So 9 pi over 3 is just 3 pi. So this devolves into sine of 3 pi. And this one, well, wait, did I goof up on this one? Ooh, wait a minute. This is actually interesting, right? Okay, thank goodness I actually talked about this. Okay, well, what happens when... Oh, wait. I'm sorry. Well, that's always good times. Well, this is a good thing I checked, right? Okay. Thank goodness I went on this tangent after all. So we have sine of 3 pi. This answer is actually wrong. And then we have sine of 3 pi. That's going to be, this is going to be half circle, which is pi, but we want 3 pi. So that's one full extra rotation, which takes us to right here, which is just 3 pi. That still takes us to an interquadrant angle, but that is collapsed triangle. Not this collapsed triangle. It's actually going to be the sideways collapsed triangle. So this interquadrant angle right here, where in the opposite is non-existent. So we count that as 0. And then the hypotenuse is existent, so it's going to be some 0. It's going to be a 0 over some number that's not 0, which is going to be equal to 0. So this is the answer, and then the one that I got before is not the right answer, because I don't know why I treated it as pi over 2. Whoops. So going back to here, we have sine of pi. Pi is the interquadrant angle, which is not this one. I don't know why I put it as this one right here is pi over 2. This is pi. So we're not dealing with that one. We are instead dealing with this one, as mentioned in this side tangent. Okay. So again, this is going to be the quote-unquote collapsed triangle situation, where the opposite is 0, and then the hypotenuse is non-zero. So 0 over non-zero is going to give us 0. Okay, so those two should match up, as they now match up. So this is the final answer for the first problem, and I think we are done. So the whole point of this part was just to illustrate that getting the coterminal angle to this base for pi over 3, it didn't matter for the problem. So this part right here is a little extra. This is all we need to evaluate the function right here. Alright. Let me make sure to cross this out, lest I do it again by accident. And next up, we are going to have to deal with tangent. So tangent of 5x over 6. That's the argument, and then that's going to be equal to 1. And then we have this thing right here. Do recall what this is. That's just going to be our domain restriction. So basically, this part right here means that we don't have infinite answers for this part right there. Because typically for a lot of these problems, if you don't have any domain restrictions, it's going to be an infinite amount of coterminal angles that will get you this particular ratio. But we do have restrictions. Alright. Standard situation, we're just going to pretend that we don't see that this is going to be 5x over 6. Just look at it as one particular angle, like theta, for example. So tangent of something gives us 1. So we just need to be concerned with where do we get the ratios of 1 to 1, or negative 1 to negative 1. So the triangle could possibly be in quadrant 1, where the adjacent is the exact same magnitude as the opposite. So opposite over adjacent is 1. That's just going to be the classic pi over 4. And of course we can have another triangle in quadrant 3. That's where the adjacent is negative 1 and then the opposite is negative 1. So negative 1 over negative 1 gives us positive 1. So what is this particular angle? Don't just capture the reference angle. The reference angle right here is pi over 4. But the actual angle that we desire is going to be this whole thing. So from here, starting from the neutral 0 to all the way to right there. So that's pi over 4 past half circle. So pi plus pi over 4. So from here to there, it's going to be 5 pi over 4. Which might not totally be relevant. And let me mention why. Let's just take this answer right here. So we figured that this whole thing, again, just pretend it's one whole angle theta. So this whole thing of 5x over 6, if you make it equal to pi over 4 as an input, then that will produce a ratio of 1 to 1. Alright. But this one is just one of many answers, ignoring the domain restrictions for a moment. So this one right here, in order to capture all the answers, you can... This is going to be the base coterminal angle, the smallest positive angle that will produce a ratio of 1 to 1. But the coterminal angles are going to be plus 2 pi. So yes, we can put plus 2 pi right here. 2 pi k, where k is again an integer. Just to encapsulate all the coterminal angles if we didn't have this domain restriction, which we're going to reconcile at the end. So like ignore these restrictions for now. So pay attention to just this one. And so this one will get you this particular angle and all its coterminal angles. But the funny thing about tangent is that you can actually capture this other triangle answer using this pi over 4 as a base answer. So instead of writing 2 pi k to get the coterminal angle to the base pi over 4, you can instead just add half circle, and that'll take you to the other triangle. So what that means is we're going to forego writing this 2 in the front. Because to get to the next relevant triangle that satisfies this particular ratio, you just need to add half circle. So just add half a circle. You don't need to add 2 pi to get to the next relevant triangle that satisfies this particular ratio. Again, it's a quirk of the tangent. It doesn't work with the sine, and it doesn't work with the cosine. It just works with the tangent, because tangent is inherently some sort of sine to cosine ratio, like this. Tangent, you can always transform into a ratio of sine x to cosine of x, and this is going to be one of the properties that you will need. I'm going to introduce this again in a separate problem, but just understand that this dynamic here means that there's a certain repetition of ratios right there. Well, again, more on that later. I just want to introduce this idea for this situation. So what I'm saying is you don't need to split this into scenario number 1. You don't need to call this scenario number 1 and call this one scenario number 2, because you can merge these two scenarios into one clean scenario, which is just going to be this one without the 2 coefficient. Okay, so that 2 coefficient is gone. We can encapsulate the triangle in quadrant 1 with the triangle in quadrant 3 by simply adding increments of pi, which is just half circle. So you can see that k could be equal to 1, and then all you do is add 1 half circle. So it goes from here as the base angle to this one if k is equal to 1. Or if k is equal to 2, you're adding a full circle from the base. So it'll be base angle plus full circle, which takes you back to quadrant 1. So if k is an odd value, it'll take you to the reference triangle in quadrant 3. But if k is an even number, even integer, then it will take you to the reference triangle in quadrant 1. Or it could be a negative. So if the magnitude is even, then it takes you to quadrant 1 as a reference triangle. If the magnitude ends up being odd, then it takes us to the quadrant 3 reference triangle. So again, this is just a keeping good form. We can combine two scenarios into one clean equation, one clean answer notation, rather than having two. I hope that's clear. So there it is. Alright. So we just solved for x. Again, we encapsulated both of these reference triangle scenarios into one clean answer, technically infinite answers, and now we need to solve for x, because we haven't solved for x. All we did was we came up with the situations where 5 times x over 6 has to equal this thing. But again, solve for x. This is just basic algebra at this point. Multiply both sides of the equation. 6 over 5. So thereby getting x isolated on the left-hand side, and then on the right-hand side, multiplied by 6/5. Should show work. All right, so this derivative property, we are going to get 3 pi over, what is that, 3 pi over 10? And then distribute this into that one. We're going to get kind of a disgusting looking 6 pi over 5k. We maintain that k is just simply an integer. Okay, so if we did not have this domain restriction, then we would report this as the final answer. But now we got to consider the domain restrictions because this one's saying infinite angles that will satisfy this situation. But we do have walls to deal with. All right. So again, how do we do that? Well, you can list all the answers if you wish. We're going to start with this base angle. So it's going to be 3 pi over 10. We know that that's going to satisfy. If we take this one and we plug it directly in, that should satisfy the situation. We should probably check that afterwards. But let's list some of these other answers as well. So first answer is if k is equal to 0. And then if k is equal to 1, that should take us to the next possible answer candidate. So all you need to do is add this number to this number, right? So I'm going to change the denominator just to make the mathematics a little easier for me. So it'll be 12 pi over 10k. I mean, over 10 times k in the numerator, of course. So when dealing this one, all we're doing is adding additional 12s to the top. And that's going to be the pattern, because once we match the denominators, we're just adding variations. We're just adding multiples of 12 or subtracting multiples of 12. So to get from the base answer candidate to subsequent candidates, just add 12 over and over again. So plus the first 12 is 15 pi over 10. Yep. And then to get to the next candidate, just add another 12 pi to the numerator. So we're going to get 27 pi. So how do we know when to stop? Well, take a look at the wall. 2 pi. You can see that the 27 over the 10 is greater than 2. So this answer here is already greater than 2 pi, which is well past our wall. So thus, cut it off there. So that one works, and then this one works. We now need to travel in the other directions where we get negative answers. So now we're subtracting 12 pi from the numerator to get our other candidates. So minus 12 from the top gives us negative 9 pi over 10. 9 is clearly less than 10, so we are still within the barrier, within domain restriction. Let's take away one more 12 from the top. So negative 9 minus 12 is going to be negative 21 pi over 10. 21 over 10 is already, the magnitude is already greater than 2. Put a negative in front. So this thing right here is going to be less than negative 2 pi, which means we're past the restriction wall. And thus, this answer, we will also omit it. So we only have 3 good answers for the situation. So that's going to be negative 9 pi over 10, positive 3 pi over 10, and then lastly, 15 pi over 10. And that's it for that one. But again, just to double check a little bit of the work, let's take this random one, and then we'll plug it into there. And we'll see if it works out. It should work out, you know, but you never know. If I goofed up on something, then this whole thing is messed up, just like the first problem, right? So, again, taking this one as a sample just to test our answer hypotheses, we'll just plug it directly in there into the x. So what do we get? We're going to get tangent of 5 over 6 times 15 pi over 10. And our question is, will it be equal to 1? We just want to verify this. And of course, make sure you always simplify before you multiply. Divide by 5, divide by 5. And then divide by 3, divide by 3. So thus yielding, still question mark, we still don't know if it's equal to 1. Thus yielding tangent of left over 5 pi over leftover of 4. And where's that? That is a triangle, reference triangle produced in quadrant 3 with a ratio of -1 opposite to -1 adjacent, which means it's going to be +1. So basically confirmed 15 pi over 10. That means that we have great confidence that these other two answers should be good as well. Again, unless the math got screwed up somewhere along the way, but we're good for this particular problem. So that is the second problem for today. Moving on, of course. We are going to have 2 cosine. Oh, no, I'm using a different color. Whoops. Let me go back to dark purple. So we have 2 cosine squared x and then minus cosine x is equal to 1. And this is basically the type of problem where you just need to solve for x. It does look a little weird because now you have a squaring. I don't think we've dealt with these quite yet in prior streams, but except we have. This is an old familiar face, and I hope you recognize it. Different masks, same monsters. Doesn't this one look exactly like this particular problem right here? Isn't that the good old quadratic? So when you solve for quadratic, all you need to do is move everything over to one side, set up for zero product property, and then factorize using your favorite factoring method, of course. We're going to get something like this. Factors of 1 and factors of 2 that produce negative is just 1, 1. Very simple numbers right here. The larger of the two magnitudes is going to be negative. So this is 2x, this is only 1x, so the negative goes on the larger 2 product, and then the positive goes right there. And then that's how we set up this particular problem into the zero product property to solve for x. Well, guess what? It's going to be the exact same thing for this particular problem, except now we got to deal with the trig at the end. So it's just one more additional thing. So you treat it first as just a quadratic problem, and then after you do the quadratic, then you do the trig problem. Alright, so let me delete that real quick, just to make room, clear the visual clutter. So this is back to the problem. Again, this one is simply a quadratic situation. Learn to recognize those ones. Anytime you have exponent 2 and exponent 1, it's probably going to be some sort of quadratic situation. So we're going to subtract 1 from both sides of the equation, thus yielding 2 times cosine squared x minus cosine x minus 1 is equal to 0. Again, zero product property setup, because this is going to be a factorizable quadratic as we've confirmed with the example. So it's going to be 2 times cosine of just x times what? So factors of 2, 2 and 1, and then factors of negative 1, 1 and 1. One of them has to be a negative. We know that this thing number 1 multiplied through thing number 2 has to produce 2 cosine squared x. If this is going to be cosine power 1x, then this one is also going to be cosine power 1x. I think I said that non-standardly, but that's okay. That's okay. So again, this one times this one produces this. That's just basically distributive property of a 2 by 2. And then, of course, factors of this one will just be 1 and 1. And going through the same motions again, the 2 times the 1 has to give us the negative, and then the 1 times the 1 has to give us the positive. So just old things just popping back up, but nothing to be worried about. We've already worked with these. Okay, equals 0. So we thus have 2 factors. Factor number 1, we're going to set that equal to 0, and then we have factor number 2. We're going to set that one to 0 as well. So let me color code this. So for this particular factor, we're going to take cosine 2 times cosine of x plus 1. We're going to force it to be equal to 0. Again, utilizing zero product property. It's a product of red thing and the blue thing. We're going to set blue thing also, the blue factor also equal to 0. So thus cosine of x minus 1 is equal to 0. Now I'm showing full work, but if you want to, you could just skip directly to cosine of x is equal to 1 if you wish. But again, most teachers typically require listing steps out. So this one we're going to get 2 cosine of x is equal to negative 1. But if you are taking a standardized test, especially multiple choice questions, please skip your work. If you have shortcuts, please use your shortcuts. This is where showing your work becomes detrimental because you lose time, essentially. Alright, so in solving for x, cosine of x is equal to negative 1/2. Classic problem at this point. It's just the type of problem we've been doing in the beginning. So sketch out the xy coordinate system. Where can our reference triangles possibly be? Well, it's a negative 1 adjacent, so we can be in quadrant 2 or we be in quadrant 3 to get that negative 1 adjacent ratio. So this one itself has 2 scenarios to deal with on top of the 2 scenarios to begin with. So that's what makes these problems particularly annoying. So many sub scenarios. So to separate those 2 scenarios, I'm going to put a little bit of color. So this one is slightly orangey. Okay, there you go. That's pretty orange, I guess. So what particular angle gets us to there? It's going to be base angle 2 pi over 3. Because again, the reference angle here is pi over 3, which means this whole angle is pi over 3 short of half circle, which is this one, which is just pi minus pi over 3, gives us 2 pi over 3. So this is just the base reference angle. The base angle. We need to get all the coterminal angles because no domain restrictions. So thus we put 2 pi k, where k is an integer. So that is scenario number 1. Wait, not scenario number 1. That's sub scenario A for scenario 1. And of course, we need to have the scenario B. That's from right here to right there. That one is just going to be pi over 3 leaking past pi. So again, the full angle from here to there is simply pi plus pi over 3. Because it's the reference angle tacked onto the half circle to get to quadrant 3. So this one right here is going to give us 4 pi over 3. But that is just the smallest positive angle that satisfies x. We need all the coterminal angles, so plus 2 pi k. Where k is an integer. So scenario B, sub-scenario B, sub-scenario A, we have successfully dealt with scenario number 1. Wonderful, right? Now we deal with the scenario 2, and hopefully this one doesn't have any sub-scenarios because it looks like an interquadrant angle. Solving for x, of course, we have ratio of 1 to 1, which means that the adjacent has an equal magnitude to with the hypotenuse. So it's 1 to 1. Where do we have such ratios of 1 to 1 for a cosine function? It's this interquadrant angle right there. The collapsed triangle, the quote-unquote collapsed triangle. So that's going to be that's going to be 0 plus 2 pi, which is full circle. Variations to get to coterminal angles, so it's going to be 0 plus 2 pi k. Nobody likes to write the 0, so just simply report 2 pi k. And that should encapsulate all the scenarios. There aren't any sub-scenario A's or sub-scenario B's. for scenario 2. So that's basically it for this particular problem. I guess we should probably clean it up. So I'm going to take this answer number 1, put it right here. It's kind of a mess. So let's bring order to disorder. So right here. And of course, this answer right there. So make sure you report all of these ones right here. Make sure you report scenario number 1, sub-scenario A, and then scenario number 1, sub-scenario B, and then scenario 2. And that should be good. This one, and that one. K is an integer, and then we'll be good to go. And just to reiterate, that was an old problem coming back. Just quadratics mixed in with trig functions. All right then, moving on to sine of 2 thirds x. And that's going to give us a ratio of -1. But if I'm saying one number, it's just not a ratio, right? So don't forget, you're always entitled to put it over 1. Now, can you put +1 over -1? Well, technically you can, but for these type of problems, in the vast majority of problems, you don't make the hypotenuse negative. One day, I promise, we're going to touch upon those situations where we have negative, quote-unquote, negative hypotenuses. But now is not the time. What do we do here? Well, I hope you recognize that this is a situation where the ratio of the hypotenuse, the ratio of the magnitude of the hypotenuse to, this is where the ratio of the opposite to the hypotenuse is 1 to 1. It's just that the negative signifies directionality. So it's a 1-to-1 ratio, which means it's an interquadrant situation, is all I'm trying to get at. So where do we get such a ratio? It's going to be this particular interquadrant angle, the one pointing downwards. This one right here. The collapsed triangle yet again, where the opposite is equal magnitude with the adjacent. But because this is a negative sign, it's the interquadrant angle going downwards, and it's not this one. That would be the +1 opposite to +1 hypotenuse. This one is +1. That, as the problem, is not +1. It's this downwards one. So what is this? Well, from the neutral, that's going to be 3 pi over 2, if you like small positive answers. But you are always entitled to put it as the negative answer. So going clockwise, you can report that this is going to be -pi over 2, if you wish. It doesn't matter, honestly. So this one would be fine, but I prefer to answer it as the smallest positive one. Keep things positive, you know. Alright, so we have this one right here. Must be the angle as a whole, as an argument result for the sine function, will give us this -1 ratio. But do we have a clean argument? No, we don't. We have a 2/3 x. So we're just going to take the 2/3 x, and we're going to equate it to the argument that we desire, which is just going to be 3 pi over 2. No domain restrictions. So you have to get all the coterminal angles, so it's going to be plus every full circle iteration gets us a relevant answer. So plus 2 pi k. So nowhere to put the plus 2 pi k here. There it is. Simple algebra. Just multiply both sides by 3/2. Solving for x. X is equal to. Kind of a gross. Oh, I almost did plus 3 plus 3. It's supposed to be times, so 3 times 3 is 9 pi. And then 2 times 2 is 4, sure. This one times this one. I'm going to... you know what? It's just going to be 6 over... No, I should simplify this. So 3 halves times 2 just gives us a clean 3. So that should be it. Again, no domain restrictions, so we have to report all coterminal angles. And this answer should be good. Let's do a quick test. So let's test it for a negative situation this time. What if the k value is -1? And we're just going to make sure the answer works out. So we have 9 pi over 4. It's going to be plus negative, so -1 3 pi. We're putting that as an argument into the sine function, and hopefully we're going to get a -1 output. Hopefully. So thus question mark. Moving forward with the test. What is that? That's going to be 9 pi over 4 minus top and bottom times 4, so minus 12 pi over 4. And thus do we get negative pi over 3. Wait, negative pi over 4. Wait, am I tripping? Oh, because we had a 2 right here. Yeah. Oh, I almost forgot. So here's where I almost goofed up, right? So right here is just the basic input, but don't forget that this problem multiplies the argument by 2/3. It has a transformation applied to the x. So that's going to be, what is that? A horizontal stretch for you graphing people. So this one I didn't even check it correctly. So this whole thing is supposed to be multiplied by 2/3. And make sure your parenthetical game is good. So it's like this. So it's like that. So it is like this. Always simplify. So simplify. And thus do we get sine of -2 pi. That's kind of alarming, isn't it? Did I goof up the answer yet again? Oh, this is what happens when I check things, when I correct things midway, unfortunately. This is supposed to be over 4, so this is still over 4. Now it should be good. Okay, so this bottom 3 cancels with the numerator 3. This numerator 2 cancels partially with the denominator 4. And thus do we get sine of -pi over 2. Hope that's correct. This one right here is going to be in interquadrant angle pointing downwards, which is going to give us -1 over 1. So thus -1. So it seems legit. And this one we got as a result from doing the 9 pi over 4 minus 3 pi. So that should be good. That was a little extra, only if you want to check your answers, but you don't always have to check your answer, especially if you're in a timed test taking situation. That clears problem 4, I think. And moving right along, we have another situation where we're given multiple statements. So statement number 1, sine of x is equal to root 2 over 2. Statement number 2, tangent of x, tanks, is equal to -1. And we're given domain restrictions, negative 10x. Wait, why do I write x? Oops. -10 pi. That's equal to x less than or equal to 10x. I mean 10 pi. I don't know why today I'm mixing up my pi's and my x's. But restriction. 2 statements. What's the question? The question is x is equal to what? So since we're not evaluating x, we have to actually specify the values of x. So basically we need to list it out. we're going to have multiple answers to list out. In contrast with the first problem. So let us do the first statement. I don't like this particular ratio. I'm going to manually change it to 1 over root 2 because this is what I prefer. So what quadrant can that possibly be in? It could be in quadrant. It could be in quadrant 1 or it could be in quadrant 3 for the 45-45 reference triangle. See that? Positive 1 to root 2. So either of these two scenarios will satisfy statement number 1. But coupled with statement number 2, opposite over adjacent, one of those need to be negative. Right here in quadrant number 1, both the adjacent and the hypotenuse, both the adjacent and the opposite are positive. How can we get a negative from that one? So thus, it is not quadrant 1. It must be quadrant 2. Just do a quick check. Positive 1 over what? Negative 1 adjacent. So this ratio does indeed give us negative 1. So we've just confirmed that x is going to be this particular base angle in quadrant 2. What is this particular angle? Well, the reference one is pi over 4, so this whole thing is pi. So we're pi over 4 short of half circle, which is going to be 3 pi over 4. Don't get too excited yet. This is just going to be the smallest positive angle. We do have domain restrictions to contend with, but I'm still going to put plus 2 pi k. So this one will give us all the answers, and then we'll start whittling them down after we consider a few things. So this one I'm going to change into common denominator with that one. So x is thus 3 pi over 4 plus 8 pi over 4 increments. Start with the base angle. It's going to be 3 pi over 4. All you need to do to get to the next candidate is add 8 to the top. So 11 pi over 4. Since this one is 10 pi, we're going to stop at 40 pi over 4. So you notice I just matched with this denominator. So once this 11 gets close to 40 or gets past it, we're going to stop. Okay, so just add one more 8 to get to the next iteration. So it's going to be 19 pi over 4. This 19 is still below the 40, so we are still within domain. So add one more 8 to that. 27 pi over 4, still good. Add one more 8 to that. 35 pi over 4, and we're going to stop right here because 35 pi is very close to this 40. Adding one more 8 is going to take us past 10 pi. So just to illustrate the point, it'll take us to 43 pi over 4. And this is well past our restriction. So that's in the positive direction. We have 1, 2, 3, 4, 5 answers up to 10 pi, but we need to go in the negative direction. Isn't that fun? That's why sometimes having the infinite answers is better than having the domain restrictions. Alright, so now we're adding negative integers of k. So k is equal to negative 1, so we're going to be subtracting 1/8 from the numerator. Takes us to negative 5 pi over 4. So minus 1 more 8. We're still ahead of negative 40 pi over 4, so keep going. So minus 1 more 8. Kind of running out of space, and let me move everything over just a smidgen. So we're going to subtract 1 more 8, so thereby getting negative 29 pi over 4. We're still above the negative 10 pi restriction, so minus 1 more 8 is going to give us negative 37 pi over 4. And hopefully I did the math right. No guarantees. The only thing I can guarantee you is my smooth melodic voice. Alright, so we have right here 37 pi over 4, and that should be good to go. We have a whopping 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A whopping 10 answers to list out, which is kind of annoying. So when you have higher coefficients for the restrictions, the more you need to list. It's not tremendously difficult, it's just kind of tedious, as you can see right there. So that should be it for this particular problem, but you know, just check one. Honestly, it shouldn't matter which one you check, but if you really, really want to be robust in your checking, you should not pick the base one. You should pick the one that's one farther away or one less, because that will tell you if this to getting to the coterminal angles is actually good or not. Because sometimes people get this right, but then they mess up the getting to the coterminal angles. I don't know. Sometimes they mess up this part. So, which means I'm going to test out I'm going to test out this one, but let me take a drink of water. Unfortunately, it's not honey tea this time. I mean, I'm sorry, it's not lemon tea anymore, because lemon dissolves your animal. Alright, so picking this one as the test candidate, we're going to take that, slam dunk it into where? It doesn't matter, you could slam dunk it here, or there. I'm just going to put it into the tangent. Into tanks. Put it into tanks. So, what are we going to get? We are going to get tangent of. So, we have no modification to the argument. It's just going to be plugged in straight as is. So, negative 5 pi over 4. That's nice. So, the question is that consistent with negative 1? So, listen. Where does that take us, right? So, from the neutral position, this is a negative argument, so we're going to go clockwise. This is going to be half circle. We're going to spill past it by pi over 4, which takes us to this 45, 45, 90 with a negative 1 adjacent and a 1 positive 1 hypotenuse. Tangent gives us the ratio of opposite over adjacent, which is consistent with this one. So, seems legit. Good to go. Next up we have sine of 3x. Which is going to give us a ratio of 1 to 2. We do have a domain restriction. It's from negative 3 pi inclusive to positive 3 pi. So, heed the domain restriction. And let's just solve for the situation. Sketch the triangle and then figure out the 3 modification and then deal with the domain restriction. So what gives us a 1 to 2 ratio for the sine function? Where do we have our reference situations? Well, we have reference angle number 1, which is right here. Positive 1 opposite over positive 2 adjacent. Hypotenuse. And then of course we have this other positive 1 situation. So positive 1 opposite to positive 2 hypotenuse. So 2 possible scenarios to begin with, but again we're going to contend with the domain restrictions afterwards. So what is this particular angle? That one is going to be pi over 6, because the small angle opens up to the small side. The root 3 is the medium one. Yeah. Which would be pi over 3. But in this case, we're dealing with the smaller opening. So pi over 3 is the base answer. So thus we set 3x is equal to pi over 6. Make sure we encapsulate the coterminal angles. So plus 2 pi k. K is integer. solving for x by multiplying both sides by 1/3, we're going to get x is equal to pi over 9, and then plus this thing divided by 3. But to reconcile, in order to capture all these answers for the domain restrictions, I'm going to change this one into denominator matching this one. So thus 4 pi over 9. Alright, and we're just going to start by listing the base angle first, so pi over 9, and then all we have to do is add increments of 4 or subtract increments of 4 until we hit wall number 1, and then later wall number 2. So base angle going forwards, quote unquote, all we need to do is add 4, so thus 4 plus 1 is 5, so 5 pi over 9. That is still well within domain restriction. We need to get up to 27 as much as we can. So 5 plus 4 is 9. Okay, that's kind of striking. Alright, next one up, 9 plus 4 is 13. Still a ways from 27. So let us add another 4. So we're going to get 17 pi over 9. Still not hitting the 27. So one more 4, if you please. So 21 pi over 9. Still not there. Add one more 4. Wow, that's actually a lot. Let me move this over real quick. And then lastly, it should be the last one. 29 pi over 9. Oh, this is past, because again, the 3 pi is equivalent to 27 pi over 9. And the 29 pi over 9 is past this restriction. So thankfully this last one is extra. So let's delete it. Okay. So now within domain, now let us go in the other direction by subtracting 4 from the base angle right here. So minus 4. It's going to be negative 3 pi over 9. You should probably simplify this. I'm kind of lazy though. So minus 4. Minus 4. Minus 4. And then should be a few more, right? A couple more. What is that? Minus 4? Minus 19 pi over 9. We haven't quite gotten close to negative 27 over 9, so let us keep going. So minus 23 pi over 9. Very close. And then if we minus one more, it takes us to negative 27 pi over 9. We stop here because that one is exactly on the wall. So hopefully that's going to be good. Let's move this one over just a bit. So unfortunately, I'm very inconsistent with how I'm writing this, but let's try to get them organized as possible. Well, that's the best I can do. Let's see, how many do we got, right? We have 1, 2, 3, 4, 5, 6 positive ones to the right of the base angle, and we have 1, 2, 3, 4, 5, 6, 7. Okay, so that's an even split. We have 7 positive answers, and then we have 7 negative answers for red scenario. That's just the red scenario, right? Well, what about the blue scenario? Isn't that wonderful? So from here to there, we're going to be pi over 6 short of half circle, which is going to be 5 pi over 6. So we're going to do the exact same setup. Let me move everything up just a little bit. So we're going to set the argument 3x is equal to that one. And of course, solving for x, I'll make sure we get all coterminal angles. So plus 2 pi k. We're going to multiply both sides by 1/3. So isolating x, we thus get x is equal to 15. I'm sorry. Simplify before you multiply, right? Okay, nothing to multiply. Simplify. So we have 5 pi over 18 plus the 2 pi over 3, which again, I'm going to match immediately with this denominator. It's going to be 2 pi 3, so we have to multiply top and bottom by 6. So it's plus 12 pi over 18. Alright. Which means for us, what does that mean? It means we're going to be adding or subtracting increments of 12 to our base answer, which is this one. So start off with the old 5 pi over 18. And all we're doing is adding 12 pi to get to subsequent candidates. So plus 12. Plus 12. Plus 12. Do we stop here? No. 3 pi is equivalent to 48. 48 pi over 18, I think. Right? Did I do that correctly? Let me think about that. 18 times 3 is... yeah, that's correct. So if we add one more 12 to the top, we will exceed the 48 pi over 18 wall. So we will stop on 41 pi over 18 in the positive direction. So these 4 answers should be good. And then now we need to proceed in the negative direction to get those ones. It's probably 4 negative answers, but let's check. So 5 minus 12 is going to be negative 7 pi over 18. Minus another 12. Fun. And then minus one more 12. Can we subtract one more 12? Let's see. Minus 12 will give us 40, negative 43 pi over 18. And this one is not quite 48, so... but it's almost there, so we're going to stop for this negative answer right there. And don't put this negative, I'm going to put a comma here just to make it clear. So we thus have 1, 2, 3, 4, which seems consistent with the 4 positive answers. So that gives me confidence that this is going to be good. Alright, let me try to clean things up just a little bit, and then we'll start to consolidate all our answers. Here's exactly what happened. It's honestly kind of a mess. Let's make sure we've dealt with everything we need to deal with, right? Okay. So we are dealing with this particular ratio. We had 2 scenarios. We had the red scenario, which is captured with all of these angles right here. And then we have the blue scenario, which is captured by all these right there. Okay. So we should be good for the problem. So if you're checking on the VOD, you can just skip if you don't want to double check the work. But I'm going to double check it. Arbitrarily picking the negative one right here. But don't write this as negative 3 pi over 9. Please write it as negative pi over 3, of course. That's your final answer. You may be docked unnecessarily for that. I don't think it's a big deal. But who knows? I'm not your teacher. So we're going to take that one and slam dunk it into there, multiply by 3, apply the sine function, and check to see if it reports back 1/2. There we go. So multiply by 3 first, and then apply the trig function, and hopefully we get the good old 1/2. Oh, it doesn't look like it's going to be good. That looks bad. Okay, so it's a good thing that that we're checking right now, right? I don't know why I'm just botching things up left and right. Well, let me backtrack this a little bit. Let me see. All right, so this definitely gives us the right ratio of 1 to 2, which is pi over 6, getting all the coterminal angles, setting it equal to 3x, which is the actual argument, and solving for x, so divide by 3. Oh, wow, how did I mess this up? Times 1/3. I don't know why I have a 9 here. Oh, okay. Wonderful. All right, so I'm going to have to redo the entire red scenario. I did the silly mistake of adding this one to the denominator where I'm supposed to multiply 1/3 to both sides. So this should have been 18 right here. This should have been 18. Yikes. Okay, so I'm going to have to do the red scenario, but the blue scenario should be good. So let me do redo the red scenario. And I think we're going to end up with a lot fewer answers. It's going to be consistent with this one, like 8 answers. Okay. But let me clear the mistake. That's such an absurd mistake as well. But these things do happen. I want to blame it on my lack of sleep, but that's just excuses. So again, we are back to resolving the red scenario. We're going to have to multiply both sides by 1/3. So solving for x, and then disturb the property. Pi over 18, not 9. So we're going to get 2 pi over 3, but again, I'm going to match the denominators. So multiply top and bottom by 6. So that will be our base answer, pi over 18. To get to the next possible candidate, we're going to add 12. So 13 pi over 18. Add another 12. 25 pi over 18. Add another 12. Already 7 pi over 18. If we add one more 12, that will take us past 48. It's going to take us to 49 pi over 18. And that one is past restriction. 49 is greater than 18 times 3. So as predicted, for positive answers, we're going to have 4. We should have 4 negative answers as well. So we're now considering negative integers for k. So minus 112 from here first. So we're going to get negative 11 pi over 18. First negative and then second negative. Subtracting 12 yet again. So negative 23 pi over 18. We should have 2 more. So minus 1 more 12. And then hopefully the last one, minus 1 more 12, is going to be 47 pi. Yes. And that one just barely makes the cut, but it does. Alright, so here we go. So we have the red scenario. This one should be correct now. Let me put this one with the rest. So we have 8 answers from the red scenario, and then we have 8 answers from the blue scenario. So that gives me great confidence that this is going to be good now. So for VOD watchers, if you wish to skip the check, you can skip the check. But I'm going to check it, just in case I made even more mistakes, right? So again, I'm going to pick this negative one right here just to check the answer. I'm going to slam dunk that into here. So thereby getting sine of 3 times negative 11 pi over 18. And we're wondering if that's going to be consistent with the 1/2. So evaluate. Cancel 3, cancel 3. We get 6 on the bottom. This is going to be negative 11 pi over 6. So that's going to be clockwise traveling. This is going to be half circle, but we are going to be 1 pi over 6 short of full circle. So this one, essentially. So that one has a positive one opposite to a root 2 hypotenuse. Did I say root 2? I'm sorry. Positive 2. This is a 30, 60, 90, not a 45, 45, 90. So 1 to 2 is consistent with 1/2, so probably good. So red scenario looks good with a quick check. This one, again, I'm not going to check using the base number angle. I'm going to check the one space over. And now in the positive direction, we're going to take that, plug it into the sine of 3x. That's going to be what? 17 pi over 18. Cancel, cancel. So thus do we get 7 and 17 pi over 6. That one's a little extra, so I'm going to subtract 1 full circle, which is 2 pi, which is 12 pi over 6. Thereby getting sine of, what is that, 5 pi over 6? Which means we are dealing with this, we are pi over 6 short of half circle, so this one. That's positive 1 opposite with a positive 2 hypotenuse, so that's going to be 1 to 2. That's what we wanted, yes. Alright, so great confidence that these 16 answers are correct. And that'll take us to the next problem, of course. It's going to be a funky one, slightly funky. What do we have? We have sine squared theta is equal to cosine squared theta. And here's a funny problem, right? Because we have trig function on the left hand side and then we have trig function on the right hand side, and they are not the same functions. So what do? We have two strats at this point. We can move everything over to one side, or we can also move everything over to one side, but two different ways. I'm going to show the first. I'm just going to show the way where we don't do any tangent properties. So we're going to take this and move it over to the left hand side. So minus cosine squared x from both sides, thus yielding sine squared theta minus cosine squared theta. That is equal to 0. Why are we doing that? Well, it's a difference of two squares, and thus we can apply our favorite factoring rule, aka difference of two squares, yes. So perfect square number 1, and this is perfect square number 2. So if you follow the algorithm, square root of that no need to worry about pluses or minuses because this algorithm takes care of it. And then this one right here, there's a minus between those, so this must be a minus plus alteration, and we get product is equal to 0. So thus 0 product property. So unfortunately we do have to use sines, property of tangents I mean. Okay, so we have product number 1, which I'm going to color blue, and then we have product number 2. So we have two scenarios. So let's set each of these factors into 0 and solve thusly. So red factor first, so sine of theta plus cosine of theta is equal to 0. That's kind of wacky, unfortunately, but here's the property you're going to need. But first we're going to subtract cosine theta from both sides, thus yielding sine theta is equal to negative cosine theta. And then here's the Here's the other step. Divide both sides by cosine of theta. So this one, anything divided by itself except for 0, keep that in mind, is going to give us just 1. But we have a negative here, so copy paste that. Here's a property that we talked briefly about maybe 2 problems or 3 problems back. It's this property that you need. Tangent of theta is going to equal to a ratio. The ratio of sine theta to cosine theta. As promised from before, we're dredging it back up. So there's the property. Please memorize it. You have to, because it's one of those basal properties. It's good for you see it again, crop it again in trig proofs. But this one, please memorize it. It'll help you out so much. All right. So that's the property. So this is quote unquote going forwards. We are quote unquote going backwards. So thus it changes to tangent of theta. Okay, so this should feel very familiar. So what possible scenarios will give us a ratio of -1 to +1 or +1 to -1? Because this is the funny trig situation. I mean the funny tangent situation. So if we have a positive opposite, then we have a negative adjacent. So it could be in quadrant number 2. For what kind of triangle? It's the opposite is equal magnitude with the adjacent. So 45, 45, 90 situation. So what angle is that one? Well, it's pi over 4 short of half circle. Therefore, 3 pi over 4. So that takes care of this particular triangle right there. And then we have the other one where the opposite is negative. And the hypotenuse, and the adjacent is positive. So quadrant 4 and quadrant 3. But again, quirk of the tangent function, these 2 scenarios you can encapsulate using just one statement. So to go from triangle number 1 in quadrant 3 to triangle number 2 in quadrant 4, all you need to do is add half circle, not full circle. So start with this. If you add 1 half circle, it takes you to the next scenario. Half a circle to get back to quadrant 3. So every iteration of pi we're adding. So thus base angle plus pi k. And that should capture all the answers. No domain restrictions. So this one should be good for the red scenario. But we have blue scenario. But as you see, it's mostly going to be the same thing. So copy paste. Almost. This is a plus. That one is a minus. We're still forcing it to be equal to 0. Forcing the 0 product property. Solving for sine of theta. So we're going to get sine of theta is equal to cosine theta. So why are we keeping the sine on one side? Well, so we can set it up for this particular property right here. Once we reach this stage, just divide sine of theta from both, cosine of theta from both sides. Divide by cosine theta. Divide by cosine theta. Anything divided by itself except for 0 is 1. This one we're going to get property right here. The ratio of sine theta over cosine theta is tangent theta. Is tangent theta familiar? So that's going to be +1 over +1, or it could be -1 over -1. But this is a quirk of tangent. We can encapsulate both scenarios by just one statement. So starting off in quadrant 1, this is going to be base angle of pi over 4. We don't want to travel full circle to get back to quadrant 1. We need to travel half circle to get to the correct reference triangle that is featured in quadrant 3. So, not full circle, half circle iterations. So, that should be answer number 2, and I think we're good to go. So, answer number 1 and answer number 2. Let me consolidate them real quick. What? Whoops. Okay. It looks like I failed to copy that. Let me try it again. Oh, here we go. Just to make things look nice. And that should be the answer. 3 pi over 4 plus pi k, and then pi over 4 plus pi k. The important question is, can we consolidate these two answers? I don't think we can. This one is in quadrant 1, which has a different ratio than the one in quadrant 2. Yes, this is plus plus, and this is minus 2 plus. So these ones are not combinable. So we can report the answer as is. And of course, doing a quick check, we're just going to add 1 pi to this one, so it's thus going to be, what is that? 7 pi over 4. So we're going to test this answer out real quick. What was it? 7 pi over 4. 7 pi over 4. Okay, just checking the answer. Plug into this one right there. Question mark, because we're not sure. Okay. So, what is that, right? That's going to be counterclockwise, almost full circle, but pi over 4 short. So that gives us negative 1 opposite to positive 1 adjacent to root 2 hypotenuse. So if we evaluate sine of this one, we're going to get negative 1 over 2. But the whole result gets squared, so that's going to be squared. And we're wondering if that's consistent with this one. So we're going to evaluate this one as well. Same reference angle, same reference triangle, so right here. What do we got? Cosine is going to be 1 over root 2. Oh, this is root 2. So 1 over root 2. And the whole thing also gets squared. So yeah, looks good. Squaring 1 over root 2 is equal to squaring 1 over root 2. The negative will cancel because of even powered exponent. So we're going to end up with 1/2 is equal to 1/2. It's consistent. So that answer should be good. And since this blue answer is so related, it's probably good as well. Or I'm just lazy. Or maybe both. Regardless, that one's knocked out. Oh, as an alt strat for that situation. So instead of forcing the difference of two squares, we could just jump straight to the sine property. I mean, straight to the tangent property, if you can see it already. So we're starting with this nonsense. We can divide both sides by cosine squared theta right away. So again, from this starting equation, we're going to divide both sides by cosine squared theta. This one divided by itself except for 0 is equal to 1. And then this one divided by cosine squared theta. This becomes a property. It's going to be tangent squared. You have the squares there. So tangent squared theta is equal to 1. So there it is. We can apply square root to both sides. But be careful when we transition from even powered exponent to odd powered exponent. You need to put plus or minus. So this one, it could be plus 1 over negative 1 or negative 1 over plus 1. So lots of different scenarios for this one. What does that mean for us? Well, we still have red scenario and blue scenario. So this one, if we arbitrarily call this one red, is that even red? Okay, it doesn't matter. The reddish looking color, then it's going to be in this particular quadrant 1. Not quadrant 1, I'm sorry. Positive 1 opposite, negative 1 adjacent ratio. So that one is the 3 pi over 4. Make sure to get the coterminal angles. Or rather, oh, the other situation, I'm sorry. So to get to the other situation with the correct ratios as well, you just add half circle. So that's the red scenario. And then, of course, dealing with blue scenario, right here, we have a negative opposite over positive adjacent. Wait, it just takes us back to, wait, does it take us back to this one? Yes, it does. Oh, yeah. Okay. So that's fine. That's fine. So this one is just captured in the red scenario. And that's if you have a, because this one itself has two answers, right? So this one could also be positive 1. So positive 1 over 1 or negative 1 over negative 1. So that's going to be this scenario or that scenario. So same thing. This first base angle here is pi over 4. To get to the next relevant reference triangle, it's just going to be plus half circle. So every increment of half circle, that should be good. So blue scenario with red scenario. And I think that's consistent with what we had before. So I was just checking the answer. Let us move on to the next scenario. So what do we have? We have here 4 sine squared x is equal to 1. So we have different strats. You can subtract 1 from both sides, or you could just divide both sides by 4 and then take the square root of both sides. Very similar to the previous problem. You can force a difference of 2 squares, solving it thusly, or you can just simply take square root. Isolate and take square root. So I'm going to use the ladder strat. So this one, divide both sides by 4 first. And then apply the square root function to both sides, thereby getting sine x is equal to 1 over root 2. But because we're transitioning from even power to odd power, we must account for plus and minus. Alright, 2 scenarios. We just need to deal with each one. So let's deal with the red scenario first. Right here. We're looking for a positive opposite over root 2 adjacent hypotenuse. So that's one scenario for the red one. But do we have another one? Oh, we do actually have another one. We have two scenarios. So sub-scenario for the red scenario. Wonderful. Alright, so I'm going to have to colorize this just a little differently. So I'm going to do with the orange one first. It's going to be pi over 4. And let me think about this. No, that's fine. So that's going to be orange scenario. And then to capture all potential situations plus 2 pi k. We could probably, there's probably going to be some overlap with this answer right there, but let's leave it alone for now. Okay, and then the other scenario is going to be this yellowish looking angle, which is going to be 3 pi over 4 plus 2 pi k. So we are done with the red scenario. Dealing with the blue scenario now, which probably also has two scenarios, sub-scenarios. Negative adjacent. Oh, I'm sorry, this is negative opposite. Yeah. Negative and opposite to root 2 hypotenuse. We could also have it in quadrant 4. Negative and opposite to root 2 hypotenuse. So from here to there, again, two scenarios. So let me use two different colors. Here is scenario number 1. That's going to be pi over 4 past halfways, because that's the reference angle. So 1 plus 4 is 5. So 5 pi over 4 is going to be the base angle answer. And then plus, full circle repeat, 2 pi k. But here's the thing though. This triangle here can be encapsulated with this one. So instead of having this answer here and this other answer there, we can combine these two. Because again, to get from quadrant 1 to quadrant 3, all you need to do is add half circle. So instead of having two separate answers with full circle rotations for the coterminal angles, we can just combine this one into one answer. We'll keep the base pi over 4. But we will change this part right here. So plus half circle rotation. Because again, this one starts us off in quadrant 1, but then if we add half circle, it takes us to quadrant 3, which is this scenario. So don't have two separate answer reports. Don't report this one and this one, which is technically correct, but we're going to consolidate them into this one. And that will be the final one for that and that. And we could probably infer the same thing for this one. This particular reference triangle is going to be in quadrant 2, but to get to this one, which is shown in the blue scenario, all you need to do is add half pi. We don't need to plus 2 pi. We need to instead put plus 1 pi to get half circle. So this is again the base angle, takes us to quadrant 2, but if we add iterations of just pi, which is half circle, it can take us to quadrant 4, which is represented with this drawing, this sketch right here. So we consider this one and we consider this one. So this answer is a combined version of this with this one. So this is transformed into this one. Alright. So we'll take that answer and we'll put it right there. And thus do we get the full answer. Answer number 1 for the orange scenario and answer number 2 for the yellow scenario. Alright, well this is actually taking a lot longer than I thought, but better to have more problems than fewer problems, right? So Next up, cosine of pi over 3 is equal to x, and then we have sine of negative pi x, which is kind of a weird setup. It's kind of a weird question, right? So what is different about this problem? Well, now we're going back to like the beginning of the trig series, where basically your input is known this time. The argument is pi over 3, so we could just evaluate this straight up and get solve for x. And all you need, once you figure out x, you just gotta slam dunk that into the second function, and we should be good to go. So that's the plan anyway. So let us evaluate cosine of pi over 3. That's in quadrant 1. It's going to be the 45, 40. It's going to be the 30, 60, 90. The 60 opens up to the greater side, which is going to be root 3. Wait, that's sine. This is cosine. Whoops. 1 to 2. Yes. So cosine should give us adjacent over hypotenuse. So that is equal to 1/2. So x is equal to 1/2. Now that we know what x is, we're going to take that and slam dunk it in there. So nothing too difficult, I think. Thus do we get sine of a negative pi over 2. I hope you recognize this one. It's just going to be interquadrant angle. It's the one that is hanging downwards. 90-degree one. Just to revisit the old thing. This is neutral position, and then we have a negative angle, so we're going to be moving clockwise. This is 90 degrees, takes us directly to this quadrant placement. So hence, interquadrant angle. It goes downwards, and then this is where the hypotenuse is equal magnitude with the opposite. So it's a 1-to-1 ratio for the opposite over hypotenuse, but it goes downwards, so that's a negative opposite. This is -1. Final answer. That was kind of fast. Alright. It's nice to mix it up with those easier problems. Next problem up. We have sine squared of 3x, and that is equal to 1/2. Fairly standard situation. You can just take square root of both sides. As a reminder, I should have mentioned this earlier, but this notation here, it means that it's going to be this whole entire thing sine of 3x, the result of which will get squared. This was mentioned in a previous stream, but this is synonymous with that. I just felt that was worth mentioning. Alright, so we're going to take the square root of both sides first, but remember, even powered to odd powered, you must put plus or minus. This thing's, it's okay, it looks nice. I'm not going to rationalize denominators, no point. Alright, well, we have this plus or minus 1 over root 2 scenario, so two major situations to think about. This positive 1 over root 2 or negative 1 over root 2. Do we need to color code again? I think we do. So red scenario is going to be positive 1 opposite over root 2 hypotenuse. Blue scenario, it's going to be negative opposite over root 2 hypotenuse. Okay, so we don't need two separate scenarios. We can just we can encapsulate both of these scenarios by adding half circle iterations. So what's this angle? What's the base angle for this one? It's going to be pi over 4. Yeah, pi over 4, and then to get to the next one, it's just going to be plus half circle plus pi. But we have a modified argument. It's 3 times x, so we set this whole thing equal to 3x. Using algebraic manipulation to solve for x. X is therefore equal to pi over 12 plus 4 pi over 12 times k. I'm going to put the k right here. Alright. So that should be it. Do we have any domain restrictions? No, we don't. So this one should be good. I should have left this in. Yeah, I shouldn't have changed this one. That's fine. Because I thought it was a restricted domain, but it's not. So no need to do this. We should have kept it as pi over 3. And that should encapsulate all the answers, I believe. Unless I slipped up somewhere along the way. But I think that's good. Let me double check. So this one is the positive one represented here. Yes. And that one is the negative one represented. Ooh, not right here because this is negative, negative. Wait. Is it? I don't know what I'm doing anymore. Okay. Well, thankfully, I did that, right? We need to check the other ones as well. Yeah, unfortunately. Okay. That's a little sloppy of me. I'm sorry. We need to report the other triangles as well. So let me go back just a little bit. But the answer right here for the orange or the gold is not incorrect. It's just half of the answer. So let me go over that again. I'm really out of it today. Okay. So just to reiterate, right, this is going to be sign for the positive scenario and then sign for the negative scenario. So the positive scenario first is when we have two positive opposites. So it could be this one in quadrant 1 or it could be that one in quadrant 2. And then for this one, that's both opposites are negative ratio. So it's going to be negative 1 to root 2 or negative 1 to root 2. So basically all the quadrants are filled. So let me now delegate it properly. So this one right here is red scenario, which takes us to this one. So the base angle for the red scenario is pi over 4, which is the answer we had before. And then plus iterations of half circle. So plus pi k. So that should be good for this one and for this one. So that takes that takes care of quadrant 1 and quadrant 3 situations. And of course, quadrant 4 and quadrant 2 scenarios. From here to there, that's going to be 3 pi over 4. And then every iteration of half circle takes us to the next relevant reference triangle. And that should be good. There we go. Where k is an integer, of course. Should always put this. Alright. And I think that should be good. I'm going to just test out one value. So let's do the one where k is equal to negative 1, and we'll do it for the blue scenario. So if k is equal to negative 1, we're subtracting half circle from this one, so it becomes negative pi over 4. We're evaluating sine squared of 3 times that. Okay, it's a good thing I decided to check the answer. I really am making a lot of mistakes today, aren't I? So this is just the base angle. We need to divide the answers by 3. Yeah. So this answer, these answers right here would be correct if this wasn't a 3x argument. If it was just sine of x, then the answers will be this one. But we do have a modification. We have a transformation inside the argument. It's 3 times the argument. So each of these we need to divide by 3. So final answer is pi over 12 plus pi over 3k. Yeah. And then answer number 2 is going to be 3 pi over 12, which simplifies into pi over 4, and then plus pi over 3k. So these ones should be correct. K is an integer. Alright. So now it should be good. This should be the final answer for the problem, but now let us check. If k is equal to negative 1, then we're going to get negative pi over 12. This is the one I'm going to test into there. Just to make sure. Alright, so we are going to have sine of 3 times this one. When we deal with this nonsense, we're going to get sine of negative pi over 4. That's going to be clockwise by pi over 4, so we are in quadrant 4. This is going to be negative 1, opposite to root 2 hypotenuse, so the ratio negative 1 over root 2. But we got to square that first. So square that, square that. So final answer is 1/2, which is consistent with 1/2. So, yep, looks good. So again, final answer is right here. How many more problems have I written? 1, 2, 3, 4, 5, 6, 7. Yeah, 7 more problems, and then, no, 6 more problems, I think. Yeah, 6 more problems. One of them is a angled expansion for angle sum, but we're not going to do that today. So let us continue. We have square root 3 sine of x plus tangent of x, tanks, and then it's going to be equal to cosine of x plus 1. So this is going to be the particular problem. There are no domain restrictions. What do we even do for this scenario, right? It looks kind of weird, honestly. Well, this is where another old thing comes back. It's very similar to polynomials. And look at the similarities, right? We have similarity of root 3 for this term, and we have root 3 for that term as a factor. This one right here consists, using the property, it's a ratio of sine x over to cosine of x. So, see how there's some coincidences? So what I'm trying to say is this is essentially going to be similar to a polynomial scenario with factoring by grouping kind of deal instead, I think. Well, let's see. Let's just move everything over to one side and see if we can factor. So move this to left-hand side, and we'll move this to left-hand side as well. So subtract this from both sides. So we want to group, we want to put the root 3 next to the root 3 for potential factor by grouping. And then we subtract 1 from both sides as well. This is not coincidence. This one ends up as something minus something else, something minus something else. Both of these have a root 3. I don't know much to say about this one at the moment. So let's factor out the root 3 from those two. So it doesn't seem tremendously useful at the moment, right? Like factoring by grouping. Well, how do we get a sine of x minus cosine x from this one as well? Well, and therein lies the rub. What is this? That's a ratio between sine of x to cosine of x. See that? See that? Minus what? That's a minus 1. So this is not quite this one, right? Well, this is going to be a common common little nifty trick in trig situations. You could always convert 1 into the ratio of cosine of x to cosine of x. So this one into that one. Why? Because we want to match this top portion with that top portion. And that's how we're going to do it. So those two group together still, and then these two, nothing, we'll just copy paste. Alright, we can factor out the 1 over cosine of x from this one. Copy paste. Again, factoring by grouping. We have a factor of sine of x minus cosine of x. Factor of sine x minus cosine x. So if you slap on the old brackets, we can factor out the parenthetical from those two terms to the outside, thereby getting sine of x minus cosine of x. Leftovers in the brackets, root 3 plus 1 over cosine of x equals 0. So thus we have a zero product property scenario as confirmed from suspicion. We'll call this one blue scenario, and then we'll call this one red scenario, or brownish looking scenario. Alright. Let's deal with the situation first. Set equal to 0. And simply just solve for x, right? Or cosine of x, I mean. It's kind of gross. We're going to perform the old switcheroo shenanigans. So we're going to get cosine of x as equal to negative 1 over root 3. Oh, I think I screwed up the problem. Yep, I messed up the problem. Okay, that's fine. That's fine. We'll continue on. And of course, dealing with this particular situation, we're going to get sine of x minus cosine x is equal to 0. And we're going to get a familiar situation. We did it a little earlier. So if you can recycle your work, please recycle your work. We're going to divide both sides by cosine of x. Thereby getting tangent of x is equal to 1. Then this one is a situation we can do. Again, we've already done this one before. This one is awful because I screwed up the numbers, but I'm going to change the problem just a little bit. So this one should have been a root 2. This one should have been a root 2 as well. Yeah. So let me change all of these. And I think it will work out. So again, changing the problem to make things work out. So technically, having it like this, keeping it like this, there is an answer to it. It's just not going to be a nice answer we're familiar with, but I want it to be a nice answer. So root 2, this changes to a root 2, this changes to a root 2. So this is a 45-90 scenario. Yeah. Alright. Back to the regularly scheduled program. We have tanks is equal to positive 1, or in other words, positive 1 over 1, or negative 1 over negative 1. I need more space. Okay, back to here we go. We have this situation. Which quadrants are we possibly in? We're in quadrant 1, or we're in quadrant 3. But these two answers can be encapsulated by one answer, so reference angle here. The base answer is going to be pi over 4. To get to the next one, just add a half circle. Half circle iteration, so plus pi k. So that's the answer for this familiar situation. Alright. Red situation, we have this one. What are we dealing with? We're dealing with 45, 45, 90 with a negative adjacent, so it could be this one. Or it could be that one. Negative 1 adjacent, still. So this one has two sub-answers. So answer number 1 is 3 pi over 4. Base angle, make sure you get all of it. This is not the tangent situation, so you need to get full circle. So plus 2 pi k. And then another scenario, it's going to be pi over 4 past pi. So 5 pi over 4. We need to capture all the answers, so it's going to be plus full circle iteration, so 2 pi k. So answer sub... Do I want to say it's so complicated? Okay, so here's one answer, here's another answer, and there's another answer. So we have 3 scenarios to report. And I think that should be good. No argument modification, right? Yeah. This is just regular x, no 3x, for example. So this answer should be good. And those 2 answers should be good. Alright. Where do we stand at this point? You know, it's almost time for dinner. I think my roommate has finished cooking up stuff. There are still how many problems left? 1, 2, 3, 4, 5, 6 problems. I'm gonna lump those up with a different set. I mean, this is a 2-hour stream. I don't want to go too far over, and also I'm hungry. So what that means is we're basically done for now. Possibly stream tonight. Don't count on it, but that'll be it for now. Have yourself a good one.